Okay, before we get started, we have some very important business to take care of. It's critical that we get this out of the way at the beginning and not later, because I might forget. Can you all say open source? Oh yeah, come on, that's so good, it's so good. Oh, I love it, that's money, thank you. Right, so, Twitter, how many of you are on the Twitters? It's 2015, I should see like everyone in the room twice. Oh, come on, you don't have like, oh, that's just, okay, well if you're on the Twitter, that's me, I'm Starbucks man. If you have email, if you have one of those email addresses that, you know, it's a new thing, all the kids do it. Email there. If you leave this room more confused than when you entered, now you have recourse. Don't hesitate to reach out to me. I am forever at your service. I am the developer advocate for the Spring team at Pivotal. How many of you have heard of Spring? Spring? Okay. Okay. Well, there's most of you. Good. So I'm a contributor to many of the different technologies there, not the least of which, of course, is Spring Boot, which we'll talk about tonight. I'm also author on 5 different books now, and 3 different videos, the latest and greatest of both of which are on Spring Boot and Spring Cloud. And I'm just I'm just really, really enthusiastic. If I had one of those giant foam thingies, that would be what I would carry, you know, for Spring, you know, #1 fan. So I am at your service. I'm not kidding. Please, if you have questions, email, okay? I work for Pivotal. How many of you know what Pivotal is? Right, so Pivotal is the new home of the Spring team. We are a small startup. We launched in April of 2013 with GE investing $100 million for like something like 10%. So we have $1 billion before we even opened our doors. We're now a small startup trying to make our way in the world. Here we are now in year 2, and what we're trying to do is to help developers build a modern platform for modern workloads, right? And a huge part of that, of course, we believe is the cloud. How many of you are on the cloud, to cloud? Microsoft talks about it, they've got a cloud. Okay, well, we believe that applications today increasingly live on the cloud, they breathe on the cloud, they have to scale well on the cloud, and that does not mean building applications in the same way as we did 10 years ago or 15 years ago. There's a new paradigm in place. So a lot of that is sort of what we care about. You may know of Spring, RabbitMQ. RabbitMQ, anyone here? Okay, distributed messaging. Redis, distributed data structure server. Anybody? Okay, going once. Apache Tomcat. Anybody? The leadership for that is on Pivotal. Okay, just wondering. Cloud Foundry, open source platform as a service. It's used by some small mom and pop shops to build their clouds. How many of you have heard of IBM Bluemix? IBM, okay. What about HP Helion? These are all distributions of Cloud Foundry, right? So Cloud Foundry is sort of the kernel to their distributions, if you will. And we happen to have our own Cloud Foundry as well, so there's that. Lots of good bits. The glue for all of this is Spring, and we said, okay, well, great. Spring is powerful. Spring has this reach that, you know, can bring you to, you know, mobile, to big data, to web services, to transaction processing, to batch, to integration, to whatever your use case. You know, microservices these days increasingly. But it can be a bit overwhelming. What can we do? I'm out of slides already. There's a pill for that, but I don't have it. So what can we do to make it easier for developers to get started, first of all, and then what can we do to sort of keep the agility, you know, increase the agility throughout the development workflow? And part of that was Spring Boot. We said, okay, well, let's tackle several different problems. We wanted to make it easy to build services, to build applications that were singly focused, small, that you could easily stand them up. They were ready for production immediately, right? That's part of it. And then we also wanted to make it so that the conceptual friction of getting started was at a minimal, right? We wanted you to have the defaults out of the box. And if you wanted to override things, we have a very powerful mechanism for doing that in Spring, dependency injection. Turns out it's actually really good for that. So we solved a lot of these different problems with Spring Boot. There are a couple ways to get started with Spring Boot. Start.spring.io is where I would go. This is a web service. It's just going to generate stuff for you. Don't freak out. This is the last you'll hear of code generation ever, I promise. It's okay. You can use this user interface. You can start this way. We'll come back to this. You can use the command line. This is one of my personal favorites. There's a very cool interface here, curl, start.spring.io, and it'll give you the menu of choices here. So if you'd like to build an application that has certain configuration. Here's all your options, and it even gives you a few curl commands. I keep hoping they're going to build a telnet interface for this, but maybe that's the next phase. Who knows? We have a command line tool as well. So if you like Groovy, how many of you are using Groovy? I know this is the Java user group, but how many of you use Groovy? Oh, okay. Groovy's awesome. So there's a CLI, and it's actually appropriately called Spring. If you have a GVM or Homebrew on OS 10, you can install it doing brew install Spring Boot. And the nice thing about that is it's very easy to get something up and running without all the overhead and ceremony of the Java language itself. So for example, touch hello.groovy, Adam hello.groovy. Hello. Oh, did you load my home directory? That's unfortunate. I would not have gone there, Adam. I wouldn't have done that. Okay, greetings, REST controller, def hi, path variable, string name. Oh boy. I'm going to return a anonymous REST message, anonymous object literal here, using Groovy syntax. This looks like a bit like a JavaScript without the brain damage. Here we go, name. Good. Spring run hello.groovy, and that's going to do some very, very crazy, sorcery and witchcraft, and it's going to look at the code in the file, and then using Groovy AST transforms, it's going to see that this type is unambiguously resolvable through a type that it knows about in this transitive graph of dependencies, and it'll automatically import that type for you, and then write the public static void main and so on. So that's all through the magic of the Groovy AST transforms. The benefit is that now I can go to localhost 8080, and what did I say? Hi, like that, right? So I get now a working REST service up and running very, very quickly. The benefit, this is just one example, and it's worth mentioning that if I were to abbreviate this, H, I don't know, maybe this will work. Let's try. This is the most crucial test of an API. Can you tweet it? Yes. Yes, I can. There you go. Now I can tweet working REST services. When was the last time you could do that in Enterprise Java? I mean it. This is a thing. This is a new place, right? So if you're looking to make, to get stuff up and running very, very concisely, very quickly, we have arrived, right? Don't waste your time on that other stack, whatever that is in this case. So that was Groovy. I grant you that is probably not what you wanted to see. So we do have an hour and a half still, so I can't really just stop here, obviously. So we're going to talk about Java. And this is, I think, more fun anyway, because we can explore all this other stuff. So going to the start.spring.io, you get to go shopping, sort of. You get to choose the kind of workloads you'd like to support in your application. You have the normal sort of usual pro forma, Maven or Gradle boilerplate, the group ID, the artifact, the name, the description, the package name, demos. That'll work, right? That's a good one. Choose the type of project you'd like to support, right? So a Maven POM or a Gradle build, or a Maven directory build, project, or a Gradle project. These are both skeletal directory structures with sort of placeholder text files in the right place, an empty class, an empty unit test, and empty application properties. We're going to leave the default, which is Maven project. Okay, we're going to choose jar or war. Now, again, this is very useful if you're in 2001. If you're stuck in 2001 and you want to deploy your Java applications to an application server, choose war. Okay. If you're in 2015, which we are, choose jar, okay? I'm a big believer in make jar, not war. Now, big believer, right? So, yes, make jar, not war, absolutely. So then you have choices now. Java version 1.6, 1.7. Okay, this is the part that always makes me uncomfortable. How many of you are on 1.6? You're among friends. No judging. No judging. You're among friends here. Anybody? 1.6? There's always that one. Where's that one guy who's always in my talks? Fine. What about 1.7? How many of you are on 1.7? Awkward. So that's end of life. Just putting that out there. I'm just going to leave that there. Just leaving it there for you. You should take it for what it's worth. Security updates are not forthcoming. I mean, security updates, but only security updates are forthcoming. So I would choose 1.8 if I could, choose a new project today. And since I can, I will. Choose the language of choice. Choose Java or Groovy. We're at the wrong user group for this, so we'll choose Java in this case, but either will do. And then choose the latest and greatest version of Spring Boot, in this case 1.2.3. And then choose the kind of things you'd like to support in your application. I'm going to choose web because I want to build a web application. I want to 80% case it. I'm going to choose JPA for SQL-based RDBMS access and all that. Great. Choose H2 for an embedded database server. These are just samples. Again, you could choose any database you'd like, but these are just ways to get off the ground and get something working. I'll choose the remote shell and actuator bits for integration with operations sort of technology. I'll choose Timeleaf for my view templates. If I were building a microservice stack and I wanted to learn more about that, I'd come back next month where I'll talk about the checkboxes in this column. But since we're not doing that today, I think that'll do. So we got web, Timeleaf, JPA, H2. Good. Hit generate, and you'll get a zip file. And I may have done this demo. I may have done it before. Okay. Awkward. So there's this. Open that up. Goodbye. Control C. Goodbye. Goodbye. Don't need. Where do I lost my Groovy script. Whatever. Can't be that important. Oops. Oh, it's loading all the things. Hold on. Whoa. Sorry, I was hacking before I got here, and now I'm being made to pay for it. Okay, here we are. I think we're home free. Good. So we have ourselves a sort of stock, otherwise very plain build file here and build structure. I'm going to increase the font size here. Font, I believe in you, bigger, okay? Good. Can you all see that? Is that legible? Absolutely. So I'm going to, it's a pretty boilerplate Maven build, nothing fancy. You don't really need that. That's just ceremony. Nor that, really. Hit enable auto import. This is a parent build. The parent build is optional, of course, but it has some benefits, not the least of which are this incredible dependency management section where we've pinned down every version of every dependency you might reasonably expect to use for these common workloads that we're supporting. Not just our dependencies, you know how hard it is to play whack-a-mole with common third-party dependencies like logging and so on among Spring Integration and Spring Batch and MVC and data and so on. But even common ecosystem libraries as well. So, Crash Hub and JSON and H2 and all the Hibernate bits and Java Assist and the logging and all that stuff. All of that stuff is sort of pinned down and leveled out, so you don't have to worry about making sure that those things work together. We didn't actually import anything for you. That you have to do yourself, right? But we did do is level set them so that if you do import them, you don't have to specify the versions. Speaking of importing stuff, each one of those checkboxes corresponds more or less to a dependency that we see here, right? So I've got my H2 database, good, we'll come back to that. I've got Spring Boot Starter Test, I've got Spring Boot Starter Web, I've got Spring Boot Starter Data JPA. All of these different dependencies are opinionated, dependency palms. They actually have no code in them. There's nothing in there. It's just a dependency that brings in other dependencies. And the reason is because we want you to have an easy way to bring in all the bits you need to be productive with one given technology stack. So for our purposes, we're going to start building something with JPA. And I want to get started with JPA. I don't really want to have to specify all the different versions I could possibly use. Take, for example, Spring-ORM. How many of you have used the ORM support in Spring? It's been around since forever and a day, right? It supports JPA 1 and JPA 2, Hibernate 3 and Hibernate 4 and Hibernate 4.1 and 4.2 and all the broken incompatible versions in between. It supports JDO, which I'm not even sure most of you remember JDO, but that was a thing 10 years ago, So this one jar, yeah, I know, the sadness in that guy's eyes. These different libraries, all, we support them all, and that's our burden. But it shouldn't be yours. It shouldn't be, it shouldn't be so painful when you want to use that library to have to manually specify or make concrete which specific technology stack you want. With Spring Boot, we decided to take a different tact. We said, let's bring everything that they're going to reasonably need to get started right now. So this brings the latest and greatest Hibernate. It brings the latest and greatest JPA. It brings in Spring support for transactions and JDBC and data sources and all that. And then you're off to the races, right? You've got everything you need. Similarly, I have all my basic unit testing support. And in my code, as I mentioned before, we have a sort of a skeletal directory structure, right? So here's my demo application test, fancy. It's using the Spring test framework and all that, so that's cool. I've got a demo application, public static void main, and one annotation. It's a Spring Boot application. You can tell because it says Spring Boot application. And I've got an empty application.properties and an empty static and templates directory, right? So that's it. The code generation didn't buy you a lot. In fact, even conceptually, it didn't really buy you a lot because all it did was add a dependency for each checkbox you checked. So really, you could have done it yourself. Now, back to our code. We have this amazing little annotation. This annotation, I'm just going to go ahead and say it. I think it was really, really poorly named. I really think they should have redone it. Nobody listens to me, but if I had my druthers, it would have been something more meaningful, like, I want to go home early. Now, this is because this turns on the magic, right? This turns on the bits that Spring Boot needs to be able to help you out. Without this, there would be no reason to be in this room, right? So this is the interesting bit. This also means that it's going to do component scanning relative to this class. So relative to the package demo, it's going to find all Spring beans underneath it or in the same package and register them if they're annotated with Spring component annotations. It also makes this class a configuration class. How many of you have played with Spring's Java configuration style? Okay, good stuff. We're going to turn that ship around eventually, man. This Java config thing is going to be big. You just watch. We introduced it in 2006. It's been around for a while. So if you get a chance, do check it out. The basic idea is that I can define, using Java, various Java objects for all of its faults. Java, it turns out, is really quite good at defining Java objects. So given a class foo, let's see, okay. No, not that one. That's not even a word. Given a class foo, if I want a bean of type foo, I can declare it like this and provide the object right there. So it's a provider method, if you will. If class foo depends on a bar, I can create a bean like that. I can say @bean bar and return a new bar. And I can stipulate that I want to get a reference to that bean injected, so I can use it in my, that's not even a word. I want to use that in my foo. I can do that here, perhaps passing it in the constructor or whatever. So it's the same kind of thing you would get if you were using the XML. It's in Java, right? And you can do all the tricks that you would normally do in Java, like ifs and elses and whatever, okay? Hopefully you won't be doing too much of this at all, but it's nice to know that that's what's happening underneath the hood. So now we've got a Spring Boot application, and we're going to build something needlessly trivial just to sort of demonstrate a point. We're going to build something that models reservations. There's surely a venture-funded app out there or something that does this already, but something that lets me make a reservation at a restaurant maybe, or something. Or just a reservation for nothing. Who knows? So we're going to build our entity first. Okay, @entity. It's a java.persistence.entity annotation there. It's going to have a primary key. So we'll say @id, @generated value. Okay. And I'm going to give it a column called reservation name. And this is Java, so we're going to make some noise. Okay. Let's see, toString. Another constructor. Okay. There we go. So that's my little entity. All it's going to do is store some state, and we'll manipulate that as we need to. I need some way to actually interface with that data, some way to talk to the data store. In this case, a SQL-based data store. Normally, that kind of logic gets put into some sort of repository code, right? If you think about the way most of us write repositories, it ends up being a class full of very, very sort of boilerplate code that, imagine find by ID or find by first name and last name or whatever. These finder methods are so nonsensically trivial to write that you can see them in your head without actually having laid fingers to keyboard, right? You can imagine what they're going to look like. And if you can imagine what they're going to look like without even having to think about it, then it's probably not something that you need to be writing in the first place. So with Spring Data, we have this idea of a repository. it is a way of declaratively, using an interface, defining repository logic, and then Spring Data will, by convention, implement that interface for you. So you say reservation repository extends JPA repository, and this is going to be a repository for entities of type reservation, which, shame on me, look at that. What is that about? Reservation. Did I just break my constructor? I did, didn't I? Awkward. Okay. Okay. Good. So now I've got an interface there, and it extends JPA repository. This is an interface that gets provided by the Spring Data JPA module. But Spring Data is itself an umbrella project. There are modules for every number of technology: Cassandra, MongoDB, Redis, Couchbase, Neo4j, Elasticsearch, Gemfire. I mean, I'm missing like 20 more. But there are modules for all of that stuff. And it's not one API to rule them all. Instead, it is the sort of common things you expect from each kind of data integration. For example, the JDBC template. How many of you know the JDBC template? Okay, so each Spring Data module will provide the equivalent, but not the same thing, of course, for the appropriate technology. So you'll have a Mongo template and a Neo4j template and so on. And we also provide this mechanism called a repository. And again, by convention, it will implement these common methods, these find all given a sorting condition, find all given a list of IDs, flush, delete, and batch, if it's supported. Otherwise, going down a level, it'll support paging and sorting if that's possible. That's not necessarily easy to do on a Couchbase or on a Cassandra, so that wouldn't be something you'd find in your Couchbase repository, for example. But a Couchbase or Cassandra could very easily support CRUD-style repository access, right? So save, delete, find one, etc. Check if it exists, etc. So this is just one type. Of course, given the right type in the class path, you can use any number of other ones. Now, going a step further, I can also implement finder methods by convention, right? So find by reservation name, string rn, whoops, like that, and that gets turned into a query behind the scenes that is more or less like this: select all from reservations where reservation underscore name equals rn, right? Again, by convention, you can override everything, of course. So at query, and plug in your own specific query in there if you like, right? Now, this is all well and good. I want to actually use this code now to actually get some data in there, and we'll see that actually working. So I'm going to define our first bean of the day, command line runner. This is an interface that Spring Boot provides, and it has one job. When the application starts up, call the run method and pass in the public static void main variadic string array from the void main method, right? So this is what you get here. This is a callback that's ideally placed for any kind of integration or batch processing or anything that doesn't have a sort of a UI or a web endpoint probably, or perhaps even those that do, right? This is just a great place to do initialization logic. So in our case, since it is an interface and it has one method, as you might imagine, this is an ideal candidate for lambdas, right? How many of you have had the pleasure of using lambdas in Java 8? Okay, so the thing you need to remember is that you have a little bit of syntax sugar here. This gets coerced into an invoke dynamic invocation behind the scenes, and it gets wrapped in an interface at runtime. So I can, instead of actually providing the interface, the anonymous implementation of the interface, I can just provide the syntax sugar here, and that will be coerced into a type of command line runner that behind the scenes will call the run method. So the language itself, it's not native function references, but it works in this case because it has one method, one abstract method in the interface. It's doing type coercion, so it actually knows that this is a string array, right? Because it knows that from the type it's coercing it to. And inside of that method, I can actually inject my reservation repository. Okay, there we go. And I'm going to save some records. So I'm going to say arrays.aslist. Peter, here we go. Got some names, split. For each name, I'll say rr.save, new reservation, passing in the name. And then I'll say rr.find all for each. And I'm going to say, for each record that I get back, remember this is a collection, a list of reservations. For each R, I want to print out the R. Now, of course, if you see what I'm doing here, you realize that I'm just calling a method inside of lambda, and this is actually a bit of extra introduction for no gain. So instead, why not just have the language call the method for me, passing in the argument that we get there. So that's a method reference. We're saying for every object in the collection, call print line with the instance. And we're going to also call find by reservation name, and we'll say, okay. Sorry? What did I do? Did I break it? Okay, so that should work. This should correctly save everything in the database and then enumerate all the data that we get back. Now, of course, you might at this point be wondering, what is this maniac talking about? What database? Where have I gone wrong? And that is a matter of convention. So remember, I have H2 on the class path. H2 is an embedded in-memory database. It's like SQLite or Derby or H2 or what's the other one? HSQLDB, the predecessor, right? So very, very nice embedded database. By convention, Spring Boot will create a data source pointing to that, absent a specific configuration that we provide. Since I haven't provided one, it'll do that for us based on the fact that that is on the class path. So it's already got a data source, and it's already working, and now I can just run it. I'm in Spring Boot, and so IntelliJ 14 knows about Spring Boot, so it's got this extra choice here. I'm not really sure what the difference is, but I always choose it because I don't want to make it unhappy. Okay. Here we go. Okay, so of course, there's our data, right? There's the records that we got. There's the find all call, right? Everything that we put in the database, printed back out. And then the specific one looking for Les specifically, right? There it is as well. Now, of course that worked. You knew that was going to work. I mean, do I look like I make mistakes besides the hair? So of course that worked, right? But actually, that's not what I really wanted to show you. This is. Now, this is very, very, very important. People struggle for years on good ASCII artwork. We, on the Spring team, have 2 PhDs, 2 people that in previous lives occupied themselves with celestial bodies in heaven. They occupied themselves with nuclear physics. They were concerned with the very essence of the universe, with star stuff. And it pleases me, it tickles me to no end to think that at some point, one of them got a GitHub issue that said, darn it, we need good ASCII artwork. And they delivered. Look at that. Now, that is really, really quality ASCII artwork. You can disable the ASCII artwork, but I don't know why you would want to do that. It's a stupid thing to do. You're not going to be able to do a better job. I mean it. Have you tried? Have you ever? No. So there is a terrible feature inside of IntelliJ now that'll actually disable that for you. And I don't know why this is here. Why is this here? Who invited you? This doesn't belong here. Anyway, terrible. So, yeah, I mean, you can change the ASCII artwork if you want, but again, recall the fable of Icarus flying too high. Anyway, so we have confirmation of data being stored in the database. Moving forward, they say that any application of sufficient complexity eventually sends email. Now, I posit that in today's day and age, an application of sufficient complexity eventually sprouts a REST API. So we're going to go back to our build here and reinstate Spring Boot Starter Web. Go back to our code. Okay. And I'm going to build a little REST API, all right? At REST controller, reservation, REST controller, at request mapping, reservations, like so. And it's going to return a collection of reservations, like that. And I'm going to do something that you should never, ever, ever do. Never. Not even when you're by yourself at home and nobody's looking. I'm going to use field injection, okay? And the reason I'm doing it is because I don't have a lot of screen buffer here, friends. I'm trying to do a demo. Your excuse is different. You should use setters and constructors. And every time you use field injection, a unit test dies. I mean it. So it's use this not, okay? Return this dot reservation repository find all, okay? Run. I'll drink some water. Oh, that's so good. Localhost 8080 reservations. There we are. So we have our, I have a pretty printing plugin in my browser. So if I were to inspect the manual curl output or whatever, I'd get that. But for our purposes, this proves what I was trying to show you, which is that it's very easy to get that up and running. I confess that I just did that to impress you. That was not actually the most efficient way to do this. I just wanted you to see that you could. In fact, I wouldn't do that, because all I'm trying to do in this case is to export my repository state as a REST service. And if you think about it, that makes a lot of sense, right? I mean, my repository is all about managing the business transitions from creation to reading to updating to deleting of my business entities. And a REST endpoint is similarly about mapping the business transitions of my business state to HTTP verbs. So we'll let the framework do that. I'm going to bring in Spring Boot starter data REST. Okay, go back here, and I'll say REST repository. Okay, and I'm going to run again. Up, and away. Whoops. Actually, you know what? I'm going to do one more thing. Kill that. Goodbye. Do svidaniya. I'm going to annotate this with a param, because in Java 8, you can actually, at runtime, using reflection, inspect the name of the arguments in a method, in a class. But in interfaces, that information is unavailable, right? So you need to provide that extra information some other way, in this case, using annotations. So now if I revisit my endpoint, hit refresh, I have the same information as I had before, in that there's my friend Les and myself and Phil and so on. But I have extra information. This is extra metadata about the resource I'm looking at. In point of fact, if I went to just /, I'd get a menu. And the menu lets me decide where I want to go next. Well, of course, for my purposes, I want to visit the reservations endpoint. Great. And when I get there, what can I do? Well, I can visit myself, and I have 3 different supported parameters. I can say reservations page equals 1 and size equals 1, and I get paging, right? So there's the one link, and I can get metadata about the payload. I get links that tell me that this is how to get back to my current resource. Here's how to get to the next page of results. Here's how to get to the previous one. And if I want to inspect the search results, the finder methods that we created, I can go to the search endpoint. And if I go to the search endpoint, you can see there's a method here. Find by reservation name, $rn equals, whatever, Peter, okay. There we go. So all of that just works based on the finder methods in the repository. These metadata links, these are very much like the link_rel text, link_rel, equals text CSS, source equals foo.css in your style sheet in your browser, right? They're a link to a document that the client, in this case the browser, needs to be able to understand or do something interesting with the payload it's looking at, which is in this case your HTML document, right? It's just expressed here in JSON in something called HAL format, right? So HAL is a way of encoding hypermedia. This is an implementation of a design pattern called HaughtyOS. Hypermedia is the engine of application state. How many of you have heard about that? Because you would have heard about it if you were in Les's talk. That would have been a thing. But if you haven't, we should talk about that some other time. Needless to say, it's very easy to add links if you like. You can just create a component of type resource processor. So you say add component, class, reservation. This one is a mouthful. Resource processor. Implements resource processor of resource of reservation. Whew. And implement that. Okay, and all I'm going to do is I'm going to say, I'm going to add a link. Perhaps each reservation has a photo attached to it or something like that. And I want to, that isn't something that my repository can automatically introspect via the interface. So I'm going to say reservation resource dot add new link. Okay, and I'm going to say http s3.com images, whatever, right? Get ID. Okay, so now I have my link there, and then the relevance in this case is that it's the profile photo. Great. And otherwise, I'm not going to do anything else. I'm just going to leave it as is. Restart. And this component, because it's registered as a component with Spring, will automatically get plugged into the pipeline. And now when I refresh the output, I see that there's a profile photo link there, right? So you can do all sorts of things to override the defaults, of course, but you get what you need out of the box. That's what I'm hoping you'll see as we move forward in this talk. Now, any questions on that so far? Nothing? Yeah, throw it out. I don't, that's like the third time somebody's asked me that, and I don't know. Sorry? Yeah, what's the fastest way without spending too much time? Plugins, is that right? Nope. Extensions. Hello? Sadness. This will have to wait. Let's take it offline. The question was, what's the pretty printing plugin? And I'm afraid I don't know. Yeah. Okay, I'll take that one. The gentleman in the back says it's JSON view. Could do. Yeah, sounds good to me. I have no idea. Oh? Sorry? Oh, you're good. You're good. Well, I believed in you. That's a terrible result. Why would you create a link to a blank thing? That's awful. Even I could do better than that. It's not even very satisfying. If it was different blank, it would, it'd make me happy, but it's not. Whatever, moving on. This wouldn't be much of a demo without some sort of, classic MVC thing, I guess. So let's go ahead and build one of those classic ones. We'll say add controller, class, reservation, MVC controller, and at alt, we'll say request mapping, and I'm going to choose some sort of nonsensical URL that nobody would in their right mind ever use in a production system ever on purpose, certainly not in like reality, today. What about like reservations.php? Okay, so we'll just use that. Reservations, and then we're going to pass in a standard Spring MVC model. This is basically a glorified hash map for keys and values so that we can dereference them from our view template. And again, doing that thing I told you not to do, I'm going to do field injection here, okay? At AutoWired, and I'm going to say return reservations, and I'm going to say model.add reservations, this.reservation repository.findAll. I'm going to get all the data there. And what this is going to do is it's going to plug in this string into a view resolver. A view resolver is a Spring MVCism. It's a heuristic that will take the string that we've given it and somehow extrapolate or derive the template path. So in this case, by convention, it's going to look in source main resources, templates, and then the string x in this case, and then suffix it with .html. Okay, so that's what it's going to arrive at when it plugs in this string. We need to actually create that template. So here we go. File, new reservations.html. And again, lazy, so I'm going to cheat. Cat desktop reservations pb copy. Okay, good. Now this is a time leaf template. Let's make sure we've got time leaf in play here. So I'm going to go back to my build and reinstate Spring Boot starter time leaf. Very good. And Timeleaf is a natural templating library. How many of you have heard of Timeleaf? Timeleaf, okay. It's a natural templating library. It's so called because you can preview it in the browser. You can open it up in your designer tools. Have you ever had that thing where you give the graphics designer your JSP page and then they give you the bird? You know what I'm talking about? Where they give you like a bag of flaming feces in front of your home. You know what I'm talking about? That one. Does that ever happen? You ever wonder why when you go to the office, the graphics designers, people look at you like they really hate you? They really do. I mean it. You gave them JSP, and now they're upset. So this is a way to not make enemies of the people that control the design. They can open this up in their tools, and it still looks like something comprehensive. Okay? Not that most of us are doing server generated. Yes, sir.
Hi, I've been using Timeleaf. I noticed there's pound signs pop up, dollar signs pop up. It seems to be quite notable.
Timeleaf has its own very, very simple property dereference syntax, and it has a few other syntax shortcuts for things like absolute paths. You can actually say at sign curly bracket and then give it a path, and it'll contextualize it. Give it these are shortcuts for template generation. But you can, as you indicate, drop into spell, and spell is the Spring expression language. It's been available since Spring 3.0. It's very powerful. I'll tell you a story in a second about spell. But yeah, you can use both, and spell is an expression language. It is definitely an expression language. Sorry?
So there's actually two separate languages.
There's the Timeleaf directives, basically, and those directives have different modalities like you indicate. And then spell is interleaved in all of that if you want, right? But all the magic, all the craziness still happens within the bounds of a syntactically interesting or valid
So more
attribute.
accurately, with the timely string integration, the things inside.
So the Spring expression language was invented by a resident mad scientist. His name is Andy Clement. He's, how many, you know the Ironman competition? You know, it's like a triathlon where you have 3 different crazy, super hard things to do. He's done it several times successfully, because when you're not writing new languages and building compilers and all that, that's what you do, right? So I was trawling the Spring 3 source code in 2009, checking subversion, which again, most of you probably don't remember, but there was this thing called subversion. And I was trawling the source code, and over 1 week, he had committed this Antler-based, and I love Terrence Parr, I'm sorry, I love Antler, but apparently it wasn't good enough for him. So he had an Antler-based implementation of the Spring expression language, which itself was a superset of anything that you could get out of the JSP or the JSF expression languages or OGNL, okay? So it did more than all of these different things. And it was just a few weeks worth of mad scientisting, right? Then, because he didn't have enough to do, the next week I checked the code, and there's this new version of the Spring expression language where he had torn out all of the Antler stuff, and he had written his own recursive descent parser for all of that stuff manually, because it was faster. And I was like, who does that? Like, anyway, it just makes me depressed, because the Spring expression language is super powerful. And now it's actually got a compiler. You can actually compile expressions now, which is great, because if you have high path, heat path based workflows where you have Spring expression language there, that's important. Anyway, so that's that, right? I'm going to go ahead and run this. Run. You can use Groovy server pages. You can use Velocity, Free Marker, Mustache. You can use JSP if you want, although we're not going to help you. You can use whatever you want, right? We're just using one of any number of choices. There's actually some really interesting work being done in Spring 4.2, which is the next and latest and greatest version of Spring, to support isomorphic templates. So you can actually have React-based views, React.js-based views, for example, and handlebars and all that stuff natively out of the framework, okay? So, okay, here's my REST endpoint. Good. All that's working. If I go to reservations.php, I have the output as we expected. I'm not a designer, but you can see it's sort of up and running, right? There we go. Good. So now that is, I think, it's not bad, right, for what little we've done. If this was the whole demo, I would say it's not bad. We've certainly established that Java can be very, very productive, even for somebody like me. Now, this isn't the whole end of the story. Remember we talked about agility? Yes, sir. Yes.
How it identifies the response page if you have the multiple same name of the
Wait, how do I what?
how it is identified that response page? This is a reservation response.
Yes.
The JSP page, right? HTML page.
HTML.
Do you have any mechanism if you have the multiple pages, how it will be identified?
I think he's asking about the database.
Oh, how does the page get resolved? Right. Fair enough. Okay. Okay, so by default, again, you're more than free to override this by providing your own bean, but by default, it plugs in the string. Where did I put it? Oh, here. It plugs in the string. It passes it to an object of type viewResolver. The viewResolver takes the string, in this case reservations, plugs it into some sort of heuristic. In this case, the heuristic is prefix it with this path, and then suffix it with that, and then that's how it arrives at the template location, which in this case corresponds to source, main, resources, templates, reservations.
If you have the multiple pages, it's 100 pages.
Yeah.
It's how it identifies. Every time it's looked at
It'll look at the string and then by convention. So if you use foo reservations, it'll look under a folder under templates called foo/reservations. Okay. My pleasure. Any other questions? That's important stuff. Anybody? Okay. Okay, so we talk about agile, and we believe very heavily in agile, right? I don't think that's, it's not very scandalous. I don't think anybody here would take issue with the idea of being agile. I don't know anybody just really, really ebullient and vehement that no, waterfall's the way, that's not a thing. But I would say that we're not all actually all that agile, right? How many of us go to production after the first, sprint? After the first iteration? Anybody? Right? Production, agile means shippable. Agile means production ready. Agile means shippable, right? And we want that to be easy. You want that to be something you care about as little as possible, but that you get right as early as possible. Because if you leave the stuff towards the end, you're going to run into trouble. How many of you have read Michael Nygaard's amazing book, Release It? Okay, well, put that on your reading list. It's awesome. It's awesome. Really great book. The very large majority of the book, while written in 2007, still holds true today, save, of course, for the bits that concern themselves with capacity planning, a concept that I'm pretty sure most of us don't worry about with the cloud today. Okay? So, sorry, how?
What is the name of the book?
It is called Release It. It's a Pragmatic Press book, amazing book. And one of the punchlines is that code complete is not the same as production ready, right? Code complete is not production ready, right? Just because you've finished all the features doesn't mean you're anywhere close to being able to put that out somewhere. And there's a whole litany of things that most applications have to have in order to integrate with production, right? A heartbeat endpoint, monitoring, analytics, all the stuff that productions and operations teams care about. Ideally, this stuff is as small and thin a veneer on top of your application as possible, but it's still something you have to care about. So we aim to make that stuff as easy as possible to add to your application. I'm going to go here and restate Spring Boot Starter Actuator and the Spring Boot Starter Remote Shell. Goodbye to you, Command V. And we'll restart the application. There we go. The application's up and running now. If I go to here, hit refresh, I'm not sure that you can see this on the screen here, but I'm wailing on the Command R as fast as I can with my arthritis-riddled fingers here. So as I make requests, I'm creating traffic. If I go to reservations, hit refresh, there we go, more refreshing. Go to /1, go to /2, go to /3, and then 3 some more, because lazy. If I go to just /, okay, refresh. I've created traffic, which I can now see if I go to the metrics endpoint, right? This endpoint is now here because of the actuator. It's views into the state of the application, things that I can tie into production monitoring and so on. So for example, I have on my machine so much memory, so many processors. This application's been up and available for so long. There's a system load right now of 3. Really? What does that even mean? Oh, the average. Probably Chrome. I have so many sessions active, in this case 0. I have so many data sources active, right? Primary usage and so on. I have 18 different requests into / reservations with a status code of type 200. I have 12 requests into / reservations / 1, 2, or 3 with a status code of 200. I have 37 requests into reservations.php, again with a status code of 200. If I go to trace, I can get a deeper glimpse into what's happening. I get a request log here. It says I've made so many HTTP requests with so many request headers and response headers. That's all here, right? If I go to env, I can see that my system properties look as follows, blah, blah, blah. And I can see what my system environment looks like as well. So there's all this. If I go to beans, I can see that my Spring application is composed of so many beans, each of which has dependencies, usefully enumerated here as the dependencies attribute. So I can see that, for example, my MVC controller is a singleton. It lives in this class, and it lives on this class literal on this, on the file system, and it has one bean dependency called reservations repository. If I go to, let me see, what else do I want to dump? Gives me a stack trace, convenient. If I go to request mapping or mappings, I can see which Spring MVC endpoints have been exposed, where they live, and which HTTP verbs, headers, parameters, etc. are required to be able to use them. So for example, if I want to go to reservations.php, I know that my demo.reservations, MVC controller.reservations method is the one that's handling that. It doesn't require a specific HTTP verb. It just works, right? So all of this stuff is exposed for free via REST, okay? I can, of course, access it from JMX. How many of you, anybody, JMX? Okay. It's the new SNMP, which is, it's going to be big one day, you just watch. So here we go. Connect, insecure, mbeans, org. Here's the same tree of information, except now I'm exposing it from JMX. So if I go to the health endpoint, which I didn't show you before, I can get data. And this data, for example, shows that the application is up. It has so much disk space, and it has a database based on the H2 stack, and it has, the data source has a connection pool, and the connection pool has a validation query, and the result of the validation query is 1. So it's basically select one from dual, or select one, or whatever, right? So all of this stuff is just automatically configured for you, and it's exported as through these JMX endpoints, okay? And similarly, here's all the other stuff, right? The metrics endpoint, operations, blah, you know, all that stuff that we saw before. My favorite way to access all this is to use the remote shell, which we also configured. I haven't plugged in Spring Security here, but if I had plugged in Spring Security, then that would be automatically picked up. But absent that, it's going to provide me a default user and a password, and this password is going to be printed on the shell by default. You can pin down a specific one if you like, but it's going to be on the shell, so I can say, okay, SSH -p 2000 user at 127.0.0.1, paste in the password. Good ASCII artwork. This is important. It's a comforting thing. It helps tame the savage beast. I get a help menu, and here I can see all the things I can do inside of this shell. I can say Java type java.lang.string. You know, I can say system prop ls, gives me all that, shows me the environment as well. If I want to do endpoints, I can do endpoint list. Here's all the endpoints that I had before. Endpoint invoke health endpoint. That should work, yeah. Same as before. My absolute favorite, you know, of course you have other specifics like metrics. This is live, so I'm not actually doing anything. It's updating the memory in situ as it's processing, of course. And my absolute favorite way to consume all this data is to the dashboard, which, for want of screen resolution, isn't looking so great. There we are, that's a little bit better. So it shows you Java top, which is awesome. And then it shows you the heap, the non-heap, the code cache, the metaspace. Again, if you're on a reasonably sized screen, this will look better, but in my case, it's PDA sized. So, so this is the Java 8 successor to PermGen. If you're in 1.6 or 1.7, you'll get PermGen instead, but same, you know, for all intents and purposes, in our case, it's the same thing. So all of that is there, and this is all just different. These are all just different views on the same information. You can, of course, disable the REST endpoints or disable whatever you want, right? There is also integration with Dropwizard metrics. So if you've ever used the Dropwizard metrics library, it in turn can talk to a whole litany of other different reporters for these gauges, these metrics, and so on. So for example, Graphite is a way of visualizing data about request streams over time. So there's a reporter for that directly. It's like syslogd. You send a message to this process, and it'll automatically visualize it for you, for anybody who's logging into the dashboard. I know of one company that is out of Los Angeles, Ticketmaster. Anybody hear of Ticketmaster? Okay, so they have re-standardized the entire service platform on Spring Boot, and they have several applications, one of which makes $50 million every hour, and that's all based on Spring Boot. And so I was very keen to sort of understand what they're doing, and they said, well, they like it all, but the one thing they had to change was they needed something that would scale a little bit better than Graphite. So they actually used Twitter's OpenTSDB, the Open Time Series Database thing, instead. But it's the same interface, it's an SPI, so you can plug in your own version and so on, and they've open sourced that bit as well. So all of this is just, you know, defaults, right? So far I've been using the defaults that we get out of the can. You can override everything, right? So, for example, I'm using an embedded web container. I suppose that part is pretty obvious at this point. First of all, I don't have to use embedded Tomcat. That's what you're getting here by default. I can use, for example, embedded Jetty. So Spring Boot starter Jetty, or I can use JBoss, Red Hat JBoss's Wildfly's Undertow engine. Undertow is the embedded, it's a servlet engine that's part of Wildfly, which is the application server formerly known as JBoss. Right? So, Wildfly, Undertow is awesome, really, really fast. So there's that. And in order to be able to use that, I need to remove or make optional my Tomcat bits. So I can just do that here. I say Spring Boot Starter Tomcat. Okay. I'm going to say scope provided. Great. So it's not going to actually be there. And this will be the only prevailing implementation on the class path. I should just be able to run it now. I like Jetty, I like Undertow, I like Tomcat, of course. By default, we're using Tomcat 8, Jetty 9, and Undertow, whatever the latest and greatest version is. They're servlet 3.1 containers. You can optionally drop down to Tomcat 7, Jetty 8, and there's no Undertow version in that case. And those are servlet 3 containers, right? So here we go. Well, first of all, the application started up. Undertow started in port 80, and so on. So it just works out of the box, right? If I hit refresh, all of that still works there. But I may want to change things, right? I can exercise a lot of control through the judicious use of properties, right? So I'm going to say server. Look at that. Isn't that cool? This is a new feature in IntelliJ. Auto-completion for the various properties that you can use in Spring Boot, and we'll look at that in a second here. So server.port can be, in this case, 8,000. And I'll say that the management bits, all the metrics and all that stuff, suppose I want to export that somewhere else. I'll say management port equals 9,000. And I want to prefix the management bits. I'll say management context path / admin. Okay? So I'm going to override how the management bits are exported on a different port, and I'm going to prefix them with / admin. And of course, then I can secure it. I can add whatever I want to lock that up under Spring Security, for example. And do I want to do anything else? I suppose I could see server. You can change all manner of things here. Anything you can actually do SSL declaratively by pointing it to the right keys and the right key stores, and it'll work for all 3 embedded implementations. You just get that out of the box.
Can you give it a management password?
Yeah. Let's see. Management. Whoa. I'm not sure if you can do that directly, but again, if you use Spring Security, then absolutely, right? Yeah. In fact, I think if you just add Spring Boot Starter Security directly, it'll require you to enter an HTTP basic prompt for the management endpoints. But I'm not sure. And since we're short on time, and I'm lazy, we'll have to figure it out later. Okay, good. So that's there. Hit refresh. As it goes, that no longer works, of course. Port 8080 is no longer a thing. / reservations, this will work, right? Reservations.php will work, but reservations, what about my metrics? Well, metrics doesn't work. If I change it to 9,000, that won't work. I still need admin, right? So / admin / metrics. Now I've moved everything over. env, there's that, beans, all that stuff is there now, right? So you can lock it down, you can move it around, you can change all sorts of different things. This is, at the end of the day, it's Spring, so Spring supports dependency injection. Dependency injection, it turns out, is a great way to change the way things behave. So for example, in our case, I want to override my health endpoint. So I'm going to create a bean, a custom bean here, and I'm going to say that I'm going to return a custom health indicator. Now remember, out of the box, Spring Boot already provides a health indicator that gets shown in the management endpoints that knows about our data source, and it knows about the disk space, and it knows about the uptime and so on. If I had RabbitMQ on the class path, it would also know about Rabbit. If I had Redis on the class path, I'd also have that. It would know about that as well. If I had Solar set up, it would know about that as well. So again, you can plug in your own and add to the collection of information that gets shown. In this case, I'm going to return my own custom health indicator. A health indicator has one job. It's a bean that you can call from any of your component code, and you can call methods like, for example, health dot, out of service, down, up, unknown, whatever, right? So in our case, I'm just going to say I heart SF jug, right? There we go. And of course, this is a ideal candidate for Lambda. So goodbye to this. Nope, nope, you can do this. I'm typing at an angle here. Okay, good. So there's my custom health indicator. I'm going to restart the application and relaunch JConsole. Okay. And go to my application. Sure. Mbeans. Endpoint, I hope. Health endpoint operations, get data. And there's my custom health indicator, right? So I'm able to change a lot of things just by the correct use of objects in this case, right? You can figure out which objects and which properties are supported through the debug, right? So there's a debug option, just -- debug. If you do that here, it's next to this completely useless icon or checkbox that you'll never use. If you click enable debug output, all that's going to do is add -- debug to your Java process, and then that'll show you all of the conditions, all of the things that Spring Boot is matching and it's trying to do when it starts up. And to understand that better, you need to understand something called auto configuration. That's the magic that we talked about earlier. See all this output here? These are all the various conditions, all the different configuration tests that Spring Boot does when it starts up that it tries to evaluate, if it can. These conditions live inside of these Java configuration classes. These Java configuration classes are detected at startup. When Spring Boot starts up, it's going to look for a file called spring.factories on the class path, and it's going to find it in a meta-inf in all the jars that have meta-inf directories. It's going to find this little text file, and inside there, it's going to find an attribute, org spring framework boot autoconfigure enable autoconfiguration equals, and then a long common delimited list of Java classes. These classes are auto configuration classes. They're just Java configuration, just as we've seen so far, for all manner of different things. RabbitMQ, Spring Batch, Spring Cloud, Persistence, Elasticsearch, JPA, Mongo, Solr, REST, Web, FreeMarker, JSON, JDBC support, JTA support, don't use that, data support, data source support, Elasticsearch, Flyway, Groovy, Lucabase, MongoDB, Mustache, Redis, security, social, Facebook, Twitter, LinkedIn, whatever, WebSockets, security, everything you can imagine. And this is just one jar. There are more. These are all auto configurations that are provided and that are attempted to be evaluated when Spring Boot starts up. I know what you're thinking. Egads. I don't want all those different types in the class path. And thankfully, you don't have to have them in the class path. So here's, for example, is the Rabbit auto configuration. It's a Java configuration class that is annotated with @conditional_on_class. This is more or less the Java equivalent of if-def. Okay, what we're saying is, if the type Rabbit template is on the class path, then evaluate the Java configuration, the bean definitions in this configuration class. Otherwise, abort. Don't bother, right? We don't want to try and set up RabbitMQ for you. If RabbitMQ isn't on the class path, then we're not going to have any luck anyway. Similarly, we're saying in this bean definition, we're saying provide an AMQP admin object, but do so only if there's no bean provided by the user of type AMQP admin, and do so only if there's no property spring.rabbitmq.dynamic that is true, right? False. So if it's false, then this will get short-circuited and won't get created. But otherwise, it'll go through. So these conditions allow us to create really, really dynamic systems. You've seen, as I've added types to the class path, things sort of, pardon the pun, spring to life, right? The actuator bits and so on. So this is how that works. And you can use this mechanism in your own code. You can create a jar, create a little text file called spring.factories, put the auto configuration in that jar. Oh, it's my guy. Put the auto configuration in that file, and then it'll get picked up whenever you have it on the class path. So if you have security and you have to get it right across your organization, all your different teams have to talk to the same identity provider. Like, for example, Stormpack. That's a great example of something you want to get right once and then not have to worry about, right?
We have a Spring Boot plugin.
They do. That's what I was trying to tell them. Yeah. So yeah, you want to do that. You want to get it right once, put it away in an auto config, and then never worry about it again. Again, this mechanism makes it possible to do that. You get consistency and agility, right? Now, this is how the auto configuration is working. I've showed you these properties, right? These properties are, by default, I'm using a application.properties. This is what it's going to look for by convention. But I could just as easily use application.yaml, right? And in point of fact, I could override all of this stuff. So if I go to the command line here, go to my code, desktop, cd demo, cd, I'm going to do maven clean install, -d skip tests because time. Okay, cd target. You'll see I have two jars, right? DUHS minus whatever is the fat jar that we get by default. That includes undertow. It's actually, this is a little counterintuitive, and I don't know really why this is true, but Tomcat is actually thinner than Jetty, which I guess I confess I don't know. And it's actually thinner than undertow. So if you want the sveltest jar, use Tomcat, but maybe that's not your big concern since, I can get half a terabyte SSD sticks now for my pocket. So du minus AHS, that's this. I can run this code, of course, like so. That's my Java application up and running. That's a jar, my friends. That contains the embedded web server. It contains SSH shell. It contains the metrics and operations integration. It contains all of Hibernate. I mean, all of it. It contains the Spring bits. It contains everything you need to build and run this application. And it works just as we expect, right? There's that as well. But suppose I want to override this, right? This is ideal, by the way, for containerized workloads. How many of you are using things like Docker? Right. Okay. So Docker, really? Guys, girls, what? Yeah, but you can run Docker on Mesos, so why wouldn't you just Docker? But Docker. Docker. Okay. Well. Anyway, this is natural because you can describe how you want to deploy and run your application. It just becomes Java minus jar. And this is very, very, very much in keeping with what we talked about earlier. Remember what I said, make jar, not war. Now, I believe in this very, very heartily, very heavily, full-throatedly. This is much simpler to operationalize than a Tomcat. And again, remember what I said earlier. Pivotal has the leadership in Tomcat. We hope you'll use Tomcat, but I'm not sure what the wisdom is in using it as an application server anymore. I'm not sure why we deploy things to other things.
But the application property, we have two different environments.
So, okay, great point. I'll come back to that in a second. What I was trying to say was, think about why we deploy to Tomcat. Most of the market is using Tomcat. If you look at most of the graphs out there, doesn't matter whose they are. My friend Arun Gupta has a great blog where he talks about how Wildfly is far and away the #1 Java EE application server, right? But again, that's less than a third of the market, right? Most of the market isn't using Java EE at all. So it's #1 and in third place, right? #2 or number one and #2. #1 is by far Tomcat. How many of you are using Tomcat? Just curious. Okay. How many of you are using Jetty? Yeah. How many of you are using, again, you're among friends. You're among friends. I give away hugs, open source hugs. How many of you are using WebLogic? Anybody? Anybody? No judging. No judging. How many of you are using WebSphere? It's okay. It's okay. Yeah. How many of you are using Wildfly? Okay, so the very large majority of you are Tomcat. And again, we have nothing to gain by telling you not to use it, but you should use it, but use it as a library, right? Most people use Tomcat because, I've seen applications where they actually check in Tomcat into the code because they have the configuration that lives in the container. So they want security and they want SSL and they want all that stuff, but it's something that they have specific to their app. So they have one app per container. How many of you deploy multiple apps to one container? Just curious. I think you're the exception. I would just venture to say most people I've seen in the community deploy one container, one app, right? They're part and parcel. They belong to each other. The configuration for the container is what I as a developer configure that for my app. And if they're so tied together, then why are they even separate things to begin with? I think in the Java and the .NET communities, we're the only ones that really have this sort of disease where we want to take perfectly good Java code and then deploy it into other Java code, right? imagine if the prevailing protocol of the day was FTP. Imagine if we were all deploying FTP-based applications instead of HTTP-based ones. Would you feel so great about deploying your Spring-based application into an FTP server? Would that feel awesome? Would you go home and talk to your kids about that? Of course not. Come on, right? So it makes no sense. We're trying to use HTTP. It's a service. If you want to speak HTTP, great, speak HTTP. But if you don't need to speak HTTP, then don't, right? Again, Java, make jar, not war. This whole idea of an extra container to add the stuff that really should be a application-specific configuration it's a thing I think whose time has come, right? So you can override the configuration for this application. Again, perhaps I want to change the configuration for the ports and so on from one environment to another. There are a few options here. I can say Java minus jar like this, and I'll say, whoops, hello, minus D server.port equals 8001 or 2. Okay, that's going to override the server.port configuration property that I put in the application.properties file. So here we go. So you can see port 9000 just as before, but now I'm overriding the default there. I can say echo server and then port 8004 application.yaml. Okay, so that should look like that. Java minus jar. There's this. It's going to be an application.yaml in the same directory, or application.properties in the same directory as my application. And now it's listening on port 8004. Okay. I mentioned Docker earlier, which is a very, very common containerized way of deploying applications. We have Lattice, which is a way of deploying and scheduling and scaling out Docker-based workloads. And Cloud Foundry, of course, also supports this in the future. So you can do, for example, export server underscore port equals 8000 and I don't know, 8, okay? So now I'm going to say Java minus jar. There's that. So in any of these examples, the input from the application, oops, I wonder who wins in that case, actually. Yeah, okay, my environment variable won, but just barely. I had a application.properties and the environment variable. I wasn't sure which one had precedence. But the point is I can externally configure via environment variables, via application.properties or application.yaml, via -d arguments, via JNDI, which I don't recommend at all, but if you have that and it's resolvable, it'll pull in values for that as well. You can configure and override all of this stuff very, very easily, right? And if you're doing Docker, again, it's way, way cool to be able to just say export, env colon and then server underscore port equals whatever. So what do we have? We have a Spring Boot application that talks to a backend database. It has a repository. It's handling transactions. We've got a REST controller. We've got MVC. We've got operations integration. We have the ability to look at the stack. We can integrate security pretty easily. We've overridden it all. We can deploy it and operationalize it. And because it's a jar, it's dead simple to deploy it to most modern cloud platforms, right? So if we have Cloud Foundry, of course, but if you're using Heroku or Cloud Foundry or Bluemix or HP or Google App Engine or whatever, a lot of them care about jars, right? This whole extra bit of indirection for a container it's for us, not for the runtime, right? Most of these clouds don't care about Tomcat or whatever. They care about running processes, killing, scaling, deploying, managing processes. So wrapping your code inside of a container, like a Tomcat, it's an extra bit of indirection. So this is a natural way to run applications. I think this is a very, very simple way to get an application up and running. What do you think so far? Yes? So far so good? Can you, yes sir?
Question about actuator. Can it be used as like a profile, memory link?
Yeah, I mean, it'll show you information about the memory that's being, managed by the container. So the question is, can you use it to profile and?
Profiling purpose?
Yeah, I suppose. I haven't tried it. I mean, I think I'd probably still use a proper profiler though, but certainly gives you a snapshot of information so you can verify that something's wrong. And if you tie it to something like a graphite, you can see, oh look, it was fine up until here, but then right around noon, boom, spike in memory or something, So it'll give you insight. If not the same thing, it's certainly one way to go. So all this to say, this is a great way to build an application. It's a great way to build a service. When you start to scale this stuff out, however, when you start to move to this new microservices-based architecture, right? This is, I use the word new with air quotes here because it's not new at all. The big web giants of they've already figured this out. They've already figured out this architecture, and they've canonicalized a lot of these patterns, a lot of the recipes for building these kinds of applications. They're already figured out. And moving to that architecture means having lots of small services, lots of small singly focused services. You've just seen that I was able to stand up a REST API. I could have configured SSL. I could have easily configured security and using OAuth or talked to Stormpath or done whatever. I could do, and it's jar, right? I can deploy that, and then like my grandpa, he could run it, Anybody who's got applets can run Java. Running Tomcat, maybe not so much, but that was Java minus jar, man. I can actually get that up and running. So it's very easy to operationalize that. When you move to this new architecture and you have lots of different services, there is friction in the interplay between these services. That is where you get into trouble, right? And managing that friction, and managing that pain is what Spring Cloud concerns itself with. It is a codification of all the patterns for building distributed systems, microservices, okay? So it builds on top of Spring Boot, so that's what I'm hoping we'll talk about next time. I think with that, I'll take questions. I mean, what do you think? Yes, no, maybe? Spring Boot? Feedback? Thoughts? Yeah. Great question. The path to upgrading is to go up here and then change this number, and then you're done. Because it manages all the dependencies for you, so it's a rising tide. As soon as you update that, it'll bring in everything else for you. You're done. That's the point, right? Where's water? So yeah, that's yep. Yes. So the question is, can the REST service have authentication? Absolutely. Like I said, there's a starter for Spring Security. Spring Security can talk to any number of backend identity providers, including Stormpath, which is an identity provider in the cloud kind of thing. Yeah, absolutely. You can talk to, I mean, by default, it's dead simple to get HTTP basic with in-memory users and roles, of course, but anything you'd like. And of course, if you're building REST apps, you probably want something like OAuth, right? Which again, that's not hard to set up with Spring Security OAuth and with this and so on. There are numerous examples, all based on Spring Boot. By the by, if you go to spring.io/guides, there's a slew of guides, each of which is about 10 to 15 minutes long from start to finish. It explains every nauseating detail of how to build and do something with Spring Boot. It does just one thing, like I want to build a REST service, great, there's a guide. I want to talk to Twitter, great, there's a guide. I want to secure a web application, great, there's a guide. And they're all mostly written in Spring Boot, in terms of Spring Boot. So you'll get common recipes for common things with Spring Boot and then whatever, right? And they're not just guides that serve, we on the Spring team don't care at all, literally at all, not even a little bit, about whether you use Angular or jQuery or React or whatever, right? We just don't care. We don't. So we gain nothing, but we have guides here that will show you how to build services that you can, and then show you how to consume them, for example, from Android, from iOS, from Angular, from jQuery, and so on. So these are not just guides on Spring, but they're guides on common ecosystem projects, right? How to build Spring Yarn projects that run on Hadoop, how to build applications that are batch processing and integration centric and so on. All that stuff is there. Okay, other questions? Yes, in the back, sir. You want to, wait, for those developers that are too lazy to what? Well, okay. So that's a great question. The question is, how do I reload code on the JVM? There's a project called Spring Loaded by the aforementioned mad scientist, Andy Clement. It was written, this is ridiculous. It was written for a Java 1 talk several years ago as just one demo of a 1-hour talk. And it does basically all the critical core functionality that JRebel does. It reloads the bytecode live. However, and this is why I'm about to say that you should use JRebel, there's a lot more to a reloading system than teaching the JVM how to reload classes. That part's actually fairly easy. The really, really hard part is teaching all the frameworks above the JVM, above the classes and the class loaders, what to do with their renewed class state, right? So you have to teach Spring MVC, you have to teach Hibernate, you have to teach whatever component model you're using, to do something interesting now that the classes have been refreshed underneath it. And that requires extensions, lots and lots of extensions. And right now, the most sort of powerful set of those extensions and the most useful technology is JRipple. So if you have the ability, I recommend JRipple. I actually did a webinar with those guys last year sometime, late last year. And they've actually got Spring Boot support kind of there, but it's getting better. There's more coming. JRipple 6 has that initial piece. And right now you can already do things like reload repositories, reload Spring MVC controllers, reload controllers and components and do all that stuff. You run into, what I would like to see is if you change the property file, then the equivalent configuration changes automatically as well. But that doesn't happen yet. So if you change application properties, it doesn't do the right thing yet. But if you change code, it does. So that's a good start. I'd check that out. Yeah?
What's next with Spring Boot?
Up and out, man. Spring Cloud is that's the big piece, right? That actually, the question is what's next in Spring Boot. We've taken this component model. There are several different great community projects that have taken this component model and built their own integrations on top of Spring Boot. So of course, Stormpath, Les and I we worked on that a little bit, and he's just done so many amazing things with it since then. What do you think, Les? Is the component model working?
Yeah, there were some minor issues, but to be fair, Stormpath Spring Boot plugin is probably one of the most complex ones out there because it provides out-of-the-box user registration screen, the forgot password, all the other stuff. But all in all, it works out really well if you're going to build custom plugins. And there's just minor hiccups around properties config, but
right.
Overall, if you understand Spring at least a little, it's pretty easy to do. He's
pushed it really, really far and then come back. Still has his hair, so that's a sign of success. There's other projects like Vaadin and Activity as a workflow engine. They support it as well. I mean, a lot of different projects are integrating it, and we're actually seeing more and more checkboxes on that start.spring.io. For Spring Boot itself, again, this is just a way of consuming Spring. So as the Spring projects update, we update as well. We're providing more and more auto configurations out of the box. I didn't show you, the actuator stuff is actually unique to Spring Boot, the actuator bits, but the rest of that is just auto configurations for Spring. Spring Data, Spring Negation, Spring Batch. We didn't click on all the checkboxes, but there's no reason we couldn't have done WebSockets and MongoDB and Hadoop and whatever. There's RabbitMQ and everything else. So I suspect what we'll see now is just more auto configurations for the rest of the Spring portfolio. I'd like to see an auto configuration for Neo4j, for example, in there, right? Just up and running. And then we continue to support and track the latest and greatest, the interesting technologies out there. So for example, Java 8 was a key theme inside of Spring, and that's reflected inside of Spring Boot support and so on. So I don't know. There's a lot of stuff there, but it really depends on what the rest of the community is doing, And a lot of the development now is on Spring Cloud. That's the bigger picture, right? Which is now that we've made it dead simple to stand up a service. Again, what does it mean to stand up? To build a system, a system that scales, that works nicely, that breathes natively in the cloud. Expands and contracts as capacity demands. So that's, I think, the most interesting use of the Spring Boot component model, Spring Cloud. It codifies a lot of the Netflix OSS component stack, the OSS stack for service registration and discovery with Eureka and Console and Zookeeper. It provides support for making smarter service-to-service invocations through things like Feign, which is a Netflix thing for declarative REST consumption, and using Hystrix for circuit breakers. It provides a centralized configuration server and integrates with things like Netflix Arceus. This is all stuff that you're going to care about at scale, right? You're going to care about when you have more than a couple of services running around. You want to make them all talk together. So this is where we are putting a lot of our energy. Spring Boot is the evolution of Spring Boot is now. It's going far, but what to me is very interesting is what all these other projects are doing, like Spring Cloud, like Stormpath, like Vaadin, like Activity, etc. So is that okay? Kind of good an answer? And again, I hope we can do the Spring Cloud talk next month. That's the one I really want to talk to you guys about. That's mind-blowing. This, I think, establishes that Spring Boot we have finally a way to make those PHP people shut up, right? There's just no reason to ever use that technology. If you're looking to be productive and be quick, we're there. We got it. The JVM delivers, finally. But Spring Cloud there's nothing else period. There's no other stack out there in any language that does that. That makes it as simple to build those kinds of systems that quickly. Yeah. Yeah. Oh, yeah. So questions about caching. Spring supports the Spring. We have the Spring cache abstraction, which predates the JCache JSR, the JCache JSR. It predates that by like 3 years. So we have implementations, for example, for Redis, for cache, for Apache Geode or Gemfire. There's implementations for Hazelcast. There's one for Infinispan from JBoss. I mean, a lot of different projects have provided their own bindings, and that provides a declarative annotation-based way of doing caching. You annotate your methods, and then the return value of the method is cached based on a key that it derives based on the arguments into the method. Or you can annotate it and specify which key to use. So that is pluggable, and there's an SPI there, and it supports also JSR 107, JCache. So any JSR 107 implementation can be used as a backend for the Spring cache abstraction, right? So that's awesome. And there's actually another project called Spring Session, which I neglected to mention, which, again, if you're trying to do distributed session replication, and there's still some apps that are using HTTP session out there. Sometimes it's unavoidable. If you're trying to do distributed session replication, there's a project called Spring Session, which acts as a proxy to the session API. And so when you write to the session API, it in turn writes to something like a Redis. So you get free session replication. You can move off of your web spheres or whatever with impunity. And that works on any platform, any runtime, any deployment, Speaking of Redis, that's the only reason I mentioned that. Other thing I forgot to mention to the first question, Grails 3, just recently released. It's based on Spring Boot, right? And JHipster is a Yaomin code generator-based approach for doing web applications, and it's also Spring Boot. So it gives you a ready-to-use web application using Angular and Spring Boot, and you can do entities and all that stuff in that code generation workflow. And that sets up Hazelcast, for example, for session replication and so on, for caching. Yep. So your check's in the mail too. Yeah, so again, that's the talk I want to give next month. That's Hystrix and the dashboard, right? Which is a circuit breaker. That's from Netflix. This is all the stuff I want to talk about next month, right?
One last question, and then we can do the giveaways.
Okay, one more question? Anybody? Going once? Yeah?
Why the name Spring Boot?
Oh, I don't know. We're just terrible with names. People keep on asking me, well, is Spring Boot about bootstrapping? No, it's not. No. I mean, Netflix is using it. Ticketmaster is using it. I mean, big companies are using this. Stormpath is using it. I mean, big companies are doing amazing things with this, in production. You don't shed it, you don't change it, you don't drop it. It's about, I don't know. And then Spring Cloud, people think, oh, well, is that like Cloud Foundry? No, it's a toolkit for building cloud native apps. It's completely different. Yeah, I don't know. It could just be called Spring Awesome, and that would have been nice, Anyway, but then I wouldn't be able to do all the, the beautiful talks and all that. So there we go. That's all I really care about is the beautiful. Email, Twitter coordinates, again, 2015, so hope you're on Twitter. Don't hesitate to reach out to me. I am, as always, your servant and your friend, Josh Long. Thank you so much for having me. I hope we can do this again next month. Let's do giveaways. Thank you so much, guys and girls and ladies.